Hello, this is the screencast for Unit 2, Sections 1 through 4. Unit 2 is on molecular and ionic compound structure and properties. Here's some optional videos. And this slideshow is posted in the Unit 2 review folder. Unit 2, the information for Unit 2 is mostly from Chapter 8 in your textbook, and there's a little bit out of Chapter 9 and Chapter 10. Section 2.1 is on types of chemical bonds. The learning objective is explain the relationship between the type of bonding and the properties of the elements participating in the bond. The essential knowledge is it's mostly about electronegativity, and the difference in electronegativity between the bonding atoms will determine the type of chemical bond. If you have a small electronegativity difference between the atoms in a bond, that's considered a non-polar covalent bond. Usually it's a difference of 0 to 0.4. And non-polar covalent means that it's a generally equal sharing of the electrons within that covalent bond. If you have a greater difference in electronegativity, usually it's considered 0.4 up to 2. That's called a polar covalent bond, where you have an unequal sharing of electrons, where the greater electronegative atom will have a greater share of the electrons and will have a partial negative charge. And then if you have a difference of difference greater than 2, that's considered an ionic bond, where you have a complete transfer of electrons. And the greater the difference in electronegativity between the bonding atoms, the more ionic character that bond will have. And then continue with 2.1, talked about ionic bonds already, but you also want to know about metallic bonds. And this picture is a representation of a metallic bond. These positive particles here, those would be the metal ions. And the negative particles, those are electrons. And the concept with metallic bonding, it's also called the sea of electron model, where the electrons are delocalized, as in they're not stuck in any one place. They're free to move around. And that's what gives metals their properties of being malleable and ductile, and they conduct heat and electricity well. 2.2 is on intramolecular force and potential energy. An intramolecular force is that's referring to covalent or ionic bonds, forces within molecules that are holding it together. The learning objective is to represent the relationship between potential energy and distance between atoms based on factors that influence the interaction strength. So the essential knowledge is a covalent bond, and you want to be able to compare potential energy versus distance. And this is a graph of that right here. You have potential energy on the y-axis, and on the x-axis right here you have the distance between the atoms. So starting off, when they're very far apart, there's no forces between the two atoms. But then if they get close enough together, then they can start to attract each other. And the attractive forces are the forces between oppositely charged particles, so from the electrons of one atom to the nucleus of the other. So once they get closer together, those attractive forces get stronger, and the potential energy will drop. Now when the atoms get too close to each other, then the repulsive forces get stronger, and the repulsive forces are between like charged particles, so between the two nuclei. So in this area of the curve, you have the attractive forces are stronger, so that's moving the atoms closer together. But in this area of the curve, the repulsive forces are stronger, and that's going to push the atoms farther apart. So in the lowest part of the curve, that's where we have the covalent bond. And what happens is the atoms will kind of cycle back and forth. They keep moving, and they cycle back and forth in this area right here. But this lowest part of that curve, that's considered where the covalent bond is. So the horizontal distance from the bottom of this curve to the 0 distance mark on the x-axis, that's considered the bond length. So if you have a shorter bond, this bond would be shifted farther left. Like if you had smaller particles that could get closer to each other, it would shift farther left. If it was a longer bond, then that bottom of the peak would be shifted to the right. And the distance from the zero potential energy to the bottom of the curve, that's considered the bond energy. And that's how much energy is released when the bond is formed, or how much energy you'll have to add to the system to break these atoms apart. So that's the bond energy. So stronger bonds will have the bottom of the curve will be lower, and weaker bonds, it'll be somewhere up here. Right? And then other essential knowledge, you also want to know bond length is proportional to bond order. Bond order is referring to single, double, or triple bonds. And you just want to know that single bonds are longer bonds and weaker. And triple bonds are shorter bonds and stronger bonds. Doubles are in between. And then you also want to know ionic bonds. What holds an ionic bond together is Coulomb's law, which is charge over distance. So if you have particles that have greater charges, it's going to be a stronger ionic bond. And if you have smaller particles that can get closer to each other, that will minimize the distance and make for a stronger ionic bond. Okay, and then we have 2.3 on structure of ionic solids. The learning objective is represent an ionic solid with a particulate model that is consistent with Coulomb's law and the properties of the constituent ions. So the essential knowledge is you just want to understand the structure of ionic solids. It's positive ions surrounded by negative ions. And if you were asked to draw these out, you'd want to show the positive ion is smaller and negative ions are larger. Because of the transfer of electrons. And these are held together by Coulombic forces. So the greater the charge on these particles and the smaller the distance, the greater the Coulombic force holding this ionic structure together. And the last part for today is on 2.4, structure of metals and alloys. The learning objective is represent a metallic solid and or alloy using a model to show essential characteristics of the structure and interactions present in the substance. So the essential knowledge is metallic bonding, and we talked about that before. That's the sea of electrons, where the electrons, the valence electrons, are free to move. And you also want to know about the two different types of alloys. An alloy is a mixture in which at least one of the substances is a metal. There's two different types, interstitial and substitutional. And it's all based on the size of the particles. An interstitial alloy, that's shown right here, that's where you have different size particles. So you have one substance that can fit in between the spaces of the other, usually the metal. An example of that would be like carbon steel, where carbon's very small and it can fit in between the spaces between the iron atoms. Substitutional alloys, that would be a picture of that right here. That's where you have similar sized particles where they just kind of replace one another. So that's all for today. Have a good day.